Okay, so after the introduction to the course, let's do an introduction to human-computer interaction. Let me say one thing about Wednesday. So Wednesday, in the first hour, we will start talking about need finding. And then in the second hour, so the one that has DSP or other courses, in the second hour, we will instead talk about the projects, the topics, etc. Examples, also projects, so that you can better understand what is the final prototype means, which is what already have an idea what is high-level fidelity, so that you can plan accordingly. So in the first hour, we'll do lecture on need finding on Wednesday, and in the second hour, we will do, instead we'll talk about projects. So even those that maybe cannot attend the first hour, if you want, you can come for the second hour, because it's a totally different topic, and we will continue talking about need finding on Monday. So with an exercise as well. So it will be split in this way. Just to clarify. So, introduction to human-computer interaction. We will do a game, let's call a game, now and then, to not to waste time, but to understand, to start to grasp some concept without me explaining to you. So the game is this. You have to list. You have the Hall of Fame, 100 position in the Hall of Fame, and the Hall of Shame, 100 position in the Hall of Shame. And I will show you something. In this moment are 5 icons. And I will ask you, do you think this is something more for the Hall of Fame, so something done so good that deserve to be in the Hall of Fame, or something so bad that deserve to be in the Hall of Shame? And then, of course, something in the middle could be a little bit more on the fame or on the shame, but example of good or bad or not so good, not so bad interfaces of some sort. And this is a simple example. And then, so first, Hall of Fame, Hall of Shame. And second, so not necessarily first position in the Hall of Fame and first position in the Hall of Shame. So not the best in the world or the worst in the world. It could be also in lower position, but in which list you would imagine to put them, and of course, why you would put them in that list. So simple, let's start simple. What are these? Let's start with the basics. Google icons of Google Apps. So looking at them, do you think that the design of these icons would go in the Hall of Fame or in some position in the Hall of Fame or in some position of the Hall of Shame? And why? Who say fame? You have to, all of them. You have to raise your hand more. You can do it. Let me count. No, keep it. Okay. And who say, what was this? The Hall of Fame? Yeah. Who said Hall of Shame? Okay. Why Hall of Fame? For consistency of the colors. Simple but memorizable. They have the same pattern, and that is similar to the same color. They are similar to colors and pattern with branded.
Most of them represent what are they doing.
Well, that's debatable. Well, also this is actually, yes, it's a document, but it's also a square, a rectangle. So let's avoid this. Hall of Shame, why?
Because it
So they are so consistent, so they are too similar. You agree? All of shame. You said fame. Ah, sorry. I was confused.
You can't understand.
Yes, they are too similar. You can, at the first glance, you cannot distinguish them. Anything else? So this is, I'm sorry for the Hall of Fame people, but this is more Hall of Shame for the reason that you said. So consistency is good in general, something to keep in mind. In general, consistency in colors, pattern is good. But this level of consistency gave you that if you put them one close to another and you have to pick quickly, because you don't see them big like this. You see them way smaller on a smartphone screen. If you have, for the first time, pick one of them, you will likely confuse which one, because they are too similar. So the previous version, where that was above, they were way less consistent, but better from the point of view of recognizing quickly the icon. Now, you now have problem in selecting opening this app if you have this app on the smartphone close one to another. You have sometimes for these reasons, but why sometimes you don't? You get used to it.
There's the name.
And then there is the name.
We don't question Google. We just use the apps.
Yeah, but you have to recognize and open the right one, no? So yes, that's sometimes, and then you get to use it. So after a while, even if they look similar, you sort of avoid errors for this. But this, if you have to design something like this, the previous version was way better, even if less consistent with the second one. Okay? So this is more, it's not terrible. We will see things way terrible, but it's not absolutely in the Hall of Fame for this change of design. Okay? But again, first lesson to learn, consistency is good. Too much consistency can be bad.
So why would they change it? Why would they change it then?
Why?
Yeah.
They decided to, well, for the branding, to give all of them the same color, and then they keep it this way. They are more consistent than the previous one, of course. They are too much. There is too much consistency here going on. A little bit probably less could have been.
So like Office icons and Adobe icons are better in consistency?
Probably. I don't remember them now, but probably. Okay, so this is the game. We will have this game sometimes, not this one exactly. We already did this. Other kind of Hall of Fame, Hall of Shame to reflect on things. In this case, consistency, that is, we will meet again consistency in a few weeks, not today, but you already have a glimpse of consistency. This was easy as a kind of exercise. So the goal of this hour is to talk about what is human-computer interaction, a little bit of what is usability that is connected to human-computer interaction, and what are the various processes to design user interface, to design user experience, and how they relate to software engineering as well, quickly. And also what is meant by user-centered design, that is one of the process. And the process we also use that is related in this area. So let's start from a little bit early. So human-computer interaction, that is back here at the back in the end of the slides, is a concept that has various other concepts related. There is a concept of devices. Could be user interface, could be interactive system, could be physical object that you interact with. It has an interface. There is a concept of performance, error, both from the technical standpoint, but also for what insists on ergonomics, human factor, our capabilities, our abilities as human beings. And then there are these, the human-computer interaction, and then the two, let's say, I'm reporting here to other way of called human-computer interaction that you may meet in the world. One is very old and in disuse, that is man-machine interaction. And the other one is still used with a different exception most of the time, that is human-machine interaction. So why man-machine interaction is not used anymore? No, well, that's not entirely true. But it's not the machine part the problem? Because you can also have women machine interaction, no? It's not that just man. So that was superseded by human. That is more like general. And then human machine interaction is still used as a general exception to include all the things that are not computers. So interaction between a person and something. So if you get an old car or some mechanical artifacts, just pure mechanic, hydraulic, things like that, is still a machine. Doesn't have any things about computers, maybe doesn't have any particular electronic either, and you can still interact with them. And it's still human-machine interaction. We talk more specifically human-computer interaction, so we avoid all, for instance, the ergonomics of the car, where you interact with the wheel in a normal car. Let's say where there is computer, but you don't interact directly with the computer in the car, if not to select music, GPS, etc., but not to drive. There is electronic there, but you operate a car like you were operating the car 30, 40, 50 years ago. With a wheel, with a lever, etc. And then there is user-centered design, that is a methodology, one classical, famous methodology to design things within these other domains. So these are concepts that are connected because, of course, human-computer interaction is interconnected with ergonomics, with human factor, especially on the machine part, but also with device, because we need to know how to use a microphone, as your colleague was saying before, and what the microphone can do, what we can do with the microphone to interact with a computer, to recognize voice, to recognize speech, etc. In brief, human-computer interaction is a field. It's a field of study that is multidisciplinary. It's a field of study that started from computer science, engineering, and psychology, and then evolved over time, including lawyers, including philosophy, including ethics, etc. So it's a huge field. But the goal is that it's concerned with the design, evaluation, and implementation of interactive computer system for human use. And with the study of the major phenomena surrounding them. So people, technology, and how to design, evaluate, and implement, realize in practice, interactive system. It involves two entities, of course, the human and the computer, that interact in the sense that each one determine the behavior of the other over time. And this determination of the behavior is framed in terms of humans' goal and humans' task and pursuit. What is a goal? Can you do an example of a human goal? Let's say in the university context, since we are here. With a computer system in within. Stay on the exam. Book an exam. That's a goal. I want to book an exam. I want to book the, give me the name of an exam. No, another exam. DSP. I want to book the future DSP exam. Okay, that's the goal. The task is how I do that. I reach the goal. How can I book the exam? Yes, and before? I'm sitting here. Turn on the computer. Then? Unlock it. Then? Open the browser. Then? Type or click the shortcut, whatever. Then log in. These are the tasks at some level of precision to fulfill that goal. And at the end, we know if the goal is fulfilled, because in theory we said we have a message or something that say you are successfully enrolled in the exam. So we have this confirmation and the goal is over, and we have another goal. Go for a walk, relax, study for DSP, whatever is the goal. So the interaction is about human goals and their task to reach this goal with a computer in the middle. So if we need to create a new interactive system for helping students enroll into exam, because the current system is too whatever, that will be a goal, and that we will need to understand the task, we need to understand which are the problems with the current system so that we can improve it or redo it from scratch. That is the interaction. It's not me and the computer talking about the day, but is the computer supporting me reaching a goal in the best way possible according to some specific task they can have. Before moving on, in this slide there are two pictures. Do you know what they are? Come on. So the first one, what is this one? These are all computer stuff. So you should know. That's a mouse. So see, you know. Which mouse? You can go and buy this. No, it's not the wrong one. It's the first mouse. The first. It's the prototype of the mouse. Created by Engelbart in the US. That is in some museum in the Computer History Museum in California. Is there. And that's the first prototype of the mouse that then 20 years after, something like that, brought to the first commercial version of the mouse. But that was the first prototype. And it's part of human-computer interaction because the mouse enables a different kind of interaction. Before the mouse, you can also only have a keyboard or other way to interact with the computer, but not point and click. That was an innovation back then. The second one is more difficult. What is? Is not a laptop. Nope. Close. Well, ancestor of? No.
Something called a data bank, something like that.
Not a data bank, but that is considered the, let's say, ancestor, the inspiration for modern tablets. This was created at Xerox PARC by Alan Kay as a portable device for children, especially to study, learn, going at school. That's a prototype. It was on paper and then was created as well. And it's considered the ancestor of the current tablet. Xerox PARC was 1920, so not exactly yesterday.
So what are the keys
for typing, for a keyboard, yes. Xerox PARC is the one that gave you object-oriented programming, and is the one that gave you Ethernet, just to give you other two, probably a little bit more famous things that emerged from Xerox PARC. This is the Dynabook. It's called the Dynabook.
1920.
I don't remember exactly, but 19 something, yes.
So the first tablet is
Look at when was discovered Ethernet, and you will find, was invented Ethernet, and you will find more or less the years.
It used paper, right?
Sorry?
It used paper.
What do you mean paper? Well, this is made on paper, but it was prototype with technology of that time, so it was a little bit heavy and not really portable, and probably the battery will last. This is just a drawing of it. Yeah, I mean, computer history is there. It's also interesting in some sort. But back to human interaction. Sorry, this was 2 examples of human interaction. Alan Kay is still alive. Probably is a little bit later than 1920. 72, 1970 then. 60, 70 was the age of Cyrus Park. That's 50 years wrong. Yes, so mid-late 1900, 20th century. And also the other one is more or less a little bit earlier. But these are two artifacts from the human interaction field. One changed the way we use computer, the other one was an inspiration for other things. And I was saying the human interaction is multidisciplinary. These are some of the disciplines that are part of it. We of course focus on more on the computer science, the computer engineering part. That is, we're building the necessary artifacts, but we also need to understand the other parts to build effective artifacts. And these other elements will help us in applying expertise in different fields and be able to talk with people and understand people in these other fields in terms of design methods, process, model, guideline, processes, convention, how to do experiment, how to do evaluation, etc. So this multidisciplinarity is what we are, I'm just hinting here in this course to you, but it's get information from various disciplines, including psychology, as I was saying before, computer science and engineer, and of course design, graphic design, industrial design as well. All of these plus others make currently human interaction as a field. And we will build on some of these, on the fundamental, at least, elements of this, and applying in our context. So what is the goal of human interaction? Human interaction, you have 3 ingredients, as I was saying before. You have the users, or the user, depends. You have the computer, and you have the task to be accomplished to fulfill a goal, as we were saying. And again, the goal of the field human interaction is that the system must support a user task or more tasks with a focus on its usability, so that the system could be potentially useful, used, and usable. These 3 characteristics we want to have. We want to have something that is not only useful, because if it's useless, why we have them? Not only used, because if no one uses it again, but also usable, because it's something usable but not useful and used, doesn't have a scope, and it's something useful and used, but it's not usable. As soon as someone did the same thing more usable, just people will move to the usable version of that same thing. So if you are a company, you will have a problem at that moment. So what we want to have is not just something nice to see and operate and usable, but also something that has a goal, a mission, a utility that is useful and can be used to a population that is just not me, but a wider number of people. So this is the goal of human-computer interaction. This is also the goal of the system we're going to create. And we are not going to go deep on any of these, on the human abilities, on the computer abilities, when it's not needed. But just to give you an idea, in a very rough idea, we have 3, let's say, systems. One is the sensory system, one is the acting system, and one is the cognitive system and processes. The sensory system are typically our senses. So visual, auditory, haptic, and also spatial, understanding where we are in space. We also have acting system, hands, voice, the head, the body. We can grasp things, etc. And then we have cognitive processes. We perceive the environment, we perceive things, we perceive colors, and we have memory, long-term memory, short-term memory, with consequences on what we can do with a computer. Also for the sensory acting and cognitive process. And we can have full, let's say, capability on all these three systems, or we can have lack as human being in one or more of the system. So maybe we have a very efficient sensory system and active system, but in this moment we got the flu and our cognitive processes are slowed down. We have a disease. We can still see, listen, hear, move, grasping, talk, etc., but we are a little bit confused, maybe. So we can have a degradation, temporary or not, of one of these processes and systems. And similarly, the computer is a map of this system. So we have the input in a computer, keyboard, mouse, microphone, sensor, card reader, webcam, etc. And we have the output, the screen, the audio, the haptics, virtual reality, augmented reality, tangible things that move, whatever can give an output from the system. And the cognitive processes are then the software we can write for a computer, in a sense. Again, we will not go in details to this, but just to keep in mind that there are limitations on both ends on what we perceive and what we cannot perceive, and what computer can do and will not. So let me talk a little bit about theory. This is probably the class that is more theoretical of the entire course, almost. I want to introduce a model of interaction, a classical model of interaction. So first of all, what is interaction? Interaction is what we said before, is humans and computer, is the computer helping, supporting the human to fulfill a goal according to some task. And the action that the human does change the behavior of the computer and vice versa. That's a general definition. But the concept can be seen in different ways. Interaction can be seen as a dialogue or a transmission. I send a message and I receive a message back. That's communication. And I could be a person sending a message to a computer, a chatbot, and receiving a message back. That is still a kind of interaction. It could be experience in terms of stream expectation, feeling, memory. I am maybe frustrated when using a computer, so that I have bad experience with the interaction of the computer, etc., etc. So different angles in which I can see this way of fulfilling my goals to fulfilling my task to reach a goal with a computing system. So again, it concerns two entities, humans and computer, that, let me repeat, determine each other behavior over time. The human determines the behavior of the computer and vice versa. The computer determines my behavior. And the mutual determination can be of many types, including statistical, mechanical, and structural. It depends what we're going to do. But the ultimate matrix, again, is people with the goal and their task. That's what we should focus on. People, the goal, and the task with a computer system to reach that goal. So let's do some assumption, or let's clear some assumption. So let's assume, that is not far from reality, that a person wants to accomplish a goal in a specific application domain. And when we talk about specific application domain, we need to keep in mind that each domain has a specific jargon, specific processes, specific sub-goal, specific artifacts, etc. If you want to teach doctors to do something in an hospital, you are in the hospital domain with the doctor expertise, and so they have specific jargon, specific sentences, specific words for identifying things. And the hospital, being an hospital, has specific rules, processes that you cannot overcome. If you want to teach the same thing to a children, you will have to switch words. You will not have the processes of an hospital, you will have the process of a house or a school that are different from. So the people has some goal, I want to learn how to swim, and according to the domain, to the person, you have to do something different to fulfill that goal. The tasks are the operation to manipulate the concept of a domain to reach that goal. And we say that the system has a state, the computer has a state, that is not the state of React, it's just state, and speaks a core language. And the human, as well, has a state that includes the understanding of the system state, my understanding of what the computer is doing, that may or may not be exactly what the computer is doing, my intention to perform a task to reach a goal, and I speak as a human being my language, the task language. I want to book an exam. That's my goal, that's my language. And the system is its own, created by developers. So we have these two entities, each one with a state of the word, and each one speaking their own language. And the user also have an understanding of the system state. So Don Norman, in that book, The Design of the Thing, with the coffee maker or the tea maker, the Bronx tea maker I showed you before, that in Italian is, I'm sorry for not the non-Italian, is called La caffettiera del masochista, because if you use it, if you use the coffee maker, you will burn yourself. There is no way you cannot burn yourself if you use that. Define in that book this model. This model say that we have the user and the system, and the user executes something on the system, and the system give back to the input something to the user for it to be evaluated. And the execution is made by 4 steps. One is establish the goal, what you want to do. The second thing is forming the intention, how I can reach the goal. Then specify the action sequence, and 4, do these actions. So let's make an example without using computer, but it's a classical example normal because these apply actually to the physical world as well. Let's say that my goal is to go out of this room from here, from where I am. So this is my goal, going out from this room. Which are the intentions I can formulate? How can I go out of this room? What I need to use to go out of this room? No, physical entities in the space. The door, which one? Because there are 4.
Depends on where you want to go.
That's forming the intention, exactly. So I have the goal, going out of the room. Forming the intention means among the 4 options, well, once I know that there is four ways to go out. We don't have a window, but maybe that's another way to go out if it's we are not the first floor. Maybe if we are ground, we can also use a window, maybe. So the intention is evaluating the options and pick one according to some criteria. So which could be the criteria here?
Want to go to the toilet?
No, that's the goal. Which will be the criteria to get to one of these 4 doors? The distance could be one criteria. If I need to go inside or outside, yeah, that could be. Or if I want to use the main entrance or the secondary, the emergency exits, that are these 2. That's just a way to say, these are things we always do. We just do it quickly. So every time we need to decide something, we do all these 4 steps. We just do it in a millisecond. But if I want to go out of this, our brain say, okay, I need to go home, I use this door, and I know how to reach this door, etc. So we do all these 4 steps immediately. This model just exemplify and separate them, but we do them every time we do an action. So I want to go out. Let's say that I want to get one of the main door, the one on my left, because yes, the one on my left. That's my intention. Then we need to specify the action sequence. Which is the action sequence? Hey, no, that's too high level. What I need to do to go to the door? And walk, that's too generic. Let's say walk like 5 steps on the left, then turn, then walk, I don't know, 20 steps on straight, and then turn on the right, walk 3 steps, and then in front of the door. What in front of the door? What I need to do? Push the door is not opening. If I push the door. Push the handle of the door cannot be open if I push the handle a little bit. What I need to do? Well, not strongly, but I need to continue to push until the door is open, and then walk other 5 steps and I'm out. So this is what we normally do, just not so slowly, more quickly. And this is the execution step. Imagine that the door is the system, which has an input, the handle, and it has an output, it opens or not. That's the steps we execute. And then there are steps in the evaluation, that is perceiving the state. This applies to doors, but also apply to people and to computer system. Perceive the state, interpreting the state, and evaluating the system state so that we can decide to do something else in the execution. This is a loop. So let's say that I go to the door and do these steps and the door doesn't open. So I perceive the system state, the door is closed, doesn't open. I interpret it as closed, and I need to evaluate to decide which is the next intention, the next steps. So why the door could not open? Sorry?
Maybe it's locked.
Maybe it's locked. So if it's locked, I can just come back 5 steps on the right and use the other door that is open. It's actually open. I don't need to push anything. So we evaluate the system. The door is locked, it's not opening for whatever reason. We think it's locked, and then we execute another strategy. And then we succeed, and so we interpret the system state, the door is open, I go out of the room, and so we can continue with another goal. Again, all of this is done instantly, but we do this every time we need to do an action or fulfilling a goal. Norman then said that when these two, the user and the system, are far away, or better, the distance between the user and the system, the gap between the two, is called the gulf of execution when there are problems in the execution line, or the gulf of evaluation when there are problems on the upper arrow. So let's make an example. Speaking about doors, let's make an example of the gulf execution. What could go wrong in the execution phase?
You could trip and fall while walking.
Sorry?
You could trip and fall while walking.
But that's, it's not in the intention in the action sequence. That's something that happens. I don't know, I'm not pushing enough, strongly enough, or instead of 3 steps, I'm doing 4 steps and I crash against the wall. My action sequence is not compliant with the goal for whatever reason. And the problem in the gulf of evaluation, that's something that I bet happens to you at least once in your life.
Push instead of pull.
Push a door instead of pulling it. So the door doesn't open, not because it's clogged, but just because that door should be pulled instead of open. That is not a problem in the execution, that's a problem in the evaluation. Why is a problem in the evaluation? Sorry, say it again.
You didn't know you had to pull, so you thought in the process that you had to push to open the door.
And who is fault? Of the person or the door?
You.
No. is the door that doesn't have, it's called the right affordances. So one thing that you will learn here is never the user fault. Is always the system. Well, this is a little bit extreme, but let's say that in an extreme way is never the user fault, is always the system fault. So if you are not able to do something with a computer system, with a door, the fault is on the system, it's not on you. Because the system didn't communicate to you the right system state. You was speaking a language that was not yours. We said before, your understanding of the system task was wrong, but not because you're stupid, but because the system state doesn't explain well what needs to be done. So in the case of the door, pushing or pulling, this is called that there is a wrong affordance. So the door is designed in a way that you instinctively, for what you learned in your story, in your life, up to the point that you want to push instead of pull. Do you looking at the door or this door, you will pull it, the end door or not? Instinctively, look at the door. You will pull or push? Push. Why? Because the handles give you the affordance of the door, or the affordance of the handle are the one that indicate that you have to push. When you don't push and pull, it's because the affordances are wrong. And it's confusing, and so it seems to push, but instead you have to pull, or vice versa. This is a good affordancy because it's clear that you have to push. You will not go there and try to pull instinctively. But this instinctively is actually doing this cycle, just very, very quickly. So the door is a classical example of normal. It's also in the book. But the same apply with a system. When you go, if you look, I don't know, the date of the discussion of the master degree. I give you a goal. Your goal is to get a degree, and you have to do the discussion and find them on the Politecnico website. Without Google, without searching. It's impossible because it's a bad done system. Yeah, because information is there, but there are no affordances for you to understand where these information are and how to reach them. So here there is a huge gap, a huge gulf between the execution or the evaluation. So you have clear what are the steps. I need to go maybe in teaching, and then a studying guide, and then thesis, and then you get lost. Because 11 clicks after, you eventually find them. So Norman say that this gulf cannot be removed. You cannot have the system and the user close one another, not to have gulf, but a good system has a gulf that is as small as possible, as reduced as possible. And this means also making system as simple as possible. Knowing them in some contexts, you cannot make it simpler than a certain point. Like, let me do an example. If you are piloting an airplane, the cockpit is not simple. It's not simple at all. There are a lot of buttons, levers, etc. And this is complex system, and that's why before piloting an airplane, you do a lot of training and a lot of studying. So the pilot, the cockpit, is as simple as possible, but it's still complex. It cannot be made simpler than that for like a intercontinental plane. So the gulf will always exist. We can try to minimize it with good user interface. We can minimize it with training, if it's specific, if it's complex. But we should minimize it, first of all, with a good communication of the output of the system for the user to understand fully the system state. Remembering that the issue is always on the system. And then there is another model that is an extension of the previous one, in which they split the user interface language from the system language, because you can have a system language according to some processes, laws, etc., but you can choose to communicate it in a different way on the user interface for your population. Let me do an example of this language, just to give you an idea. If I'm talking about credits, you know, in a university settings, you know what I'm talking about, more or less, right? What is a credit? What is related to the concept of credit? The number of hours for a course, right? So this course is a 6-credit course. That means 60 hours, currently 60 hours of in-class activity plus, I don't remember how many, 15 multiplied 6 hours of individual study from you. That's a credit. But you know, you've heard about credits. You know, the course is 6 credit, 8 credit, etc. Now, if you go to a middle school student and say, my course has 6 credit, will this person understand you? No. Same language, different context, different knowledge, different expertise. It's something easy for university students, it's something unknown for a middle school student or a high school student. Language, same concept, different language. If you talk about this course is 60 hours, will the middle school student understand? Yes. Same concept, different language. This is the same. User interface language and system language. The system can speak about credits, but the user can speak a language is more suitable for the interface can speak. A language is more suitable for the interface. Human errors that never are about humans can happen in the goal file execution of 2 kinds. One are slips, and the other one are mistakes. Slips are, I have formulated the right action, but failed to execute it. I need to double click an icon, but I'm clicking too slowly. The action is right, but I'm performing it in a way that is not producing the result. These slips are minor things that can be corrected by a better interface. Spacing, layout, removing the double click if it's not needed, etc. Tweaks, simple to do, easy to do, quick to do. And then mistakes are instead the bigger one, where I don't know the system well, and I'm not able to formulate, I don't understand the system well, and I'm not able to formulate the right goal. Like I click on this icon, thinking that it's zoom, but it's search. So I want to zoom, but I'm clicking on searching, so I have mistakes here. So in this case, the user mental model, that is the understanding of the system, is not correct. And is not the fault of the user, but is the system that should communicate better or comply with standards or best practices or principle, etc. In this case, for the system require more radical redesign or additional training if the system is already well done, but it's just complex. So it needs to be trained, like the cockpit for a pilot of an airplane. As I was saying before, errors should never be considered fault of the user, but they are typically a result of bad design, as in the case of the door before. Because people, at the end of the day, are messy, and you cannot do anything about this, really. People are imprecise, could be distracted, are absolutely not omniscient, and so the system design should try to anticipate this human behavior, minimizing error and maximizing the change, the chance of discovering, repairing, going back in case of errors, etc. and enable user to understand the state of the system and build their own appropriate model on how things work, so that they learn. Let's do an example. This is buttons, switches in a smart home in close to Aosta. So let me zoom in. When they put out these switches with these colors, gold and red, they put close to the switch some icons. These switches were in a house, in a smart home, where you have doors, opening the entrance door, doors of the other rooms, and also lights. Windows all can be controlled by these switches, by the right switch. So looking at the icons, can you understand what these switches are doing?
The first and the last are doors and windows. The one in the middle is something like that for the light, maybe. Or like a bomb.
But which light, which door? There are 3 doors in this room.
All of them.
All of them. You know, articulation is one of the bit in the execution. The fact that we are thinking which is the right button to do one thing is already a problem per se. Then maybe we guess right, or maybe we guess not right, but this is a problem. Also, why red and gold? There is a meaning for this or not? There was not a meaning, of course. And I think that the first one was the door, not the entrance door, another door, and these actually were the entrance door, and these were light. So how the people in this room, in this house, fixed it? You see a fix. They put a piece of tape, paper tape, and write what the buttons are. This opened that door with the arrow. So this is a problem of articulation, right? Articulation was here in the first step between the user language and the user interface language, where the user interface is a switch in this case.
Didn't user get the first time they use it, they will understand. So the next time it is confirmed in memory.
Yes, well, this case is more complex because this was a public house for people that got like accident in the car, etc. So people in the house always rotated. Was to helping, I have an accident, I broke my leg, I be hosted here for 1 month. And then I recover, and then another person. So they needed to highlight which are the right button because always people change. But this could have been solved with like better icons or text or whatever, right? Simple fix in this case. But the fact that we are here thinking, okay, what it's doing is making me think about what I have to do is already a problem per se. Here, look at this part. You know, what is this? This is the advanced font capability Word, Microsoft Word. Look at this part. Which are the imagine that you never used Word before. Okay? Which are the allowed combination of these 2 columns here? Because from the semantic of this button, it's a checkbox. So multiple selection, which means I can have the text that is at the same moment, strike through, double strike through, superscript, and subscript at the same moment, which of course is not possible. And same, I can have text that is all small caps or also all caps or hidden, which again is not going to happen. So this is an example of presentation. The language, of course, this work properly. It will not allow you to select strike through and double strike through. These are mutually exclusive. So it's not a problem of features, it's not a problem how it works, it's a problem how it's presented, the user interface language. These are mutually exclusive, the first two. The third and the fourth are mutually exclusive, and small caps and all caps are mutually exclusive, and it then can be applied together with the others. So if you try it in Word, this is the behavior. But if you've never seen it, and you know that a checkbox works with multiple selection, you can say, but how is it possible to have something that is both superscript and subscript? That's either stay in the top or on the bottom, cannot be stay in the both position at the same moment. It's quantum computing, in a way. So of course this works properly, so the system is implemented properly, but the user interface is not. And this is Microsoft. This is Microsoft Word used by billions of people. So it's not to say shame of them, but it's to say these things can also happen when software is so widely used. And in a small advanced part of the software, of course, it's not in the main part of the software. But still, also there you can find this kind of problem and want to try to prevent them, to design systems so that you don't have these errors anymore.
So if these kind of applications work like this and it's too complicated for the users, how they don't like make it simpler or update it in another way of the simplicity? And also, is it because it cannot be simpler than this?
No, it could be simple. Well, it could be done differently. Why Microsoft didn't do it, I have no idea. Probably is low priority. Is not one main feature of Word. It's just one window behind the advanced feature of the font, which is probably used only by a small percentage. It can be done in a proper way, like with spacing, using not checkbox, but the two. But you can design it differently. Just probably low priority for them to fix it. Maybe in Office, in 10 years, they will fix it when they solve the bigger problem they have. But still, it's an example, in this case, of the presentation. The system is working properly, but user interface is not aligned with the language of the system.
But if user has a goal, I don't think that his goal can be, I don't know how to say. The user doesn't want to do his text that is strike through and double strike through at the same time. So it will never have this problem.
Remember this. People make mistakes, but not because they are wrong, but because they are distracted, because the environment is distracted, because whatever happens in their life, we cannot assume, and we should keep in mind, we cannot assume that a person is 100% always focused on the goal, right? Because if you are using your smartphone under a heavy rain, you will be distracted by other things that happens, like keeping the umbrella open and looking at the cars and looking at the Venice that Turin becomes when it's rain, and looking at all these things. If it's a sunny day and you are alone in the same street with the same smartphone, you will be much more maybe focused because you don't have all the other distractions. So context is important. People are people. People are a mess. Let's keep this as assumption, as borderline. People are messy. People will do things in a way that you didn't imagine. And the goal of a good interface is to try to intercept this, to understand the need, the process, to understand them and work to improve them in a way with a system that is reliable to the different condition that you are. So moving on, these are the major user interface style that we have currently in computer system. let's see if you know all of them. I think so. The command line interface, make an example. The things you write in the terminal. Menus. Hmm? No, menus. wget is a command line interface. Menus. Which are menus in a user interface? It's a style different from others. A menu. What is a menu? Yeah, for instance, when you click on file, or you right-click on something, it appears a menu, a list of items you can select one from this. Natural language. Natural language. A voice assistant, or a calendar where you can say, create an appointment for tomorrow at 5, or can create an appointment, say tomorrow at 5, and then it moves in the right day, etc. So natural language. Question, answer, and query dialogue. It's sort of, again, the assistant as before. Form field. Form field. A form, yes. Sign up, login, filling out a form for an agency, for the passport, for an ID, a form that you need to file up, and then can be, or the group composition form that can be backed up by a spreadsheet.
Notifications considered as natural language.
Sorry?
Notifications are considered as natural language.
Yes. Notifications, since they are written natural language and are not anything else, are within natural language. Yes. Or query dialogue, it depends if they also have some action to do, if it's not a simple notification. Then WIMP, that is Windows icon menus a pointer. What is WIMP? Operating system, not all operating system.
The one with the GUI.
Not all with GUI. Windows, icon, menus, and pointers. Android is not a WIMP operating system. Desktop environment. You need to have Windows, icons, menus, like the file that we said, and a pointer, a mouse, a trackpad, a touchpad, something that has a pointer on the screen. And then mobile, that is touch-based, it has its own, it have or not window, it has icons, it can have menus or not, it doesn't have pointers, unless you touch a keyboard. But natively, they are not designed to have a pointer, thought to have a pointer. Then extension now, they also now have windows, but originally they're not. Point and click is also a kind of games. Point and click is when you with a mouse, you point and click is a paradigm for clicking, and also kind of games that are point and click, and three-dimensional interface, virtual reality, augmented reality, all the stuff there. These are the major user interface style, which has their own rules and characteristics, of course. So design process, I'm going quite quickly here because it's not fundamental in this moment. So there are a number of design processes. The classical one is the user-centered design that is also used in the industry and avoid risk of software project failure by around 50% of the cases. This is a very old system, design process. And the idea of the user-centered design is that for every step of the design, of the creation of a system, you involve actual user. Every single step. So it's a lot of expensive in terms of cost, in terms of energy, in terms of time, but it works and reduces software project failure in a way that is factual, evident. Very classical system, a series of process. modern, a little bit modern system participatory design. Participatory design involves user as creators. Not as I did something, try it for me, and then I modify it and I try for me. They involve people as designer, as developer, as they co-design, they co-create the interactive system together. It's a step further, more agile, but not in the agile software engineering way than the others, but you need to be more expert to do participatory design than to do user-centered design. Then there is agile interaction design that borrows the idea from the agile development in software engineering and bring it to the interface interaction design in this evolutionary development as in the agile, but quick release cycle, rapid prototyping techniques, low-cost main interaction prototype as in an agile sprint. But they also have like extreme usability. They push, in a way, the limit on some part to stay in the sprint. And then we have design thinking, that is probably the more modern of the four. That is a 5-stage non-linear iterative process that has the first step, that is research user need with empathy in mind. Emphasize. Then define the needs, then ideate, then prototype, and then test, and then repeat many of these steps. So these are, and then there is service design, that is a shift from product, from designing product, a bottle, a car, etc., to the service that is behind it. So borrow a car, lending a car, renting a car, whatever, around car. So Uber versus buying a car. That is service design. All of these have some elements in common, some methods, some techniques in common that are the one that we are going to use and we are going to explore in the course. We are not buying any of these specific systems because they are either too heavy or you need to be too expert to use it, but we pick the fundamental element of them and we put them in a simplified and generic human-centered design process similar to the user-centered design process, the original user-centered design process. And this system and this process say, let's start with what is needed from user, that's need finding, we said. Then let's move to the analysis, or how the design thinking people say define, definition, and then we design something, we prototype something, we go back to the analysis, we change the design or refine the design, we prototype something, through an evaluation we go back and stay in this cycle until time is up, we are satisfied, we ended money, whatever it happens, and we go to the final implementation and final deployment of the system, of the product, of the prototype. Usability, that we just said how well the user can use the system, is actually an ISO norm and is defined in various dimensions. Usefulness, we already met it. Learnability, memorability, efficiency, effectiveness, visibility, error, satisfaction. And all these concepts, we will meet them again when we talk about principles and guidelines to design and evaluate system, like the heuristic evaluation I mentioned before, because all of these are part of the usability. We will see the main steps during the course. We, of course, start off what is needed by people and who are these people, in which context they operate. Then we formalize the need in some way to communicate, to understand, to explore them, and then we design them according to criteria, according to the level of fidelity of the prototype that we want to do. And then we also implement, will not deploy, but we'll implement in a high fidelity prototype. So in this cycle, we will do need finding, assignment 1, assignment 2, analysis, design and the first prototype. Assignment 3, evaluation. Assignment 4, a small cycle year without evaluation. Assignment 5, a high fidelity prototype, another evaluation, and then we'll end the course. So we will do this cycle 2.5 times. In a way, with 3 different levels of fidelity for the prototype. We will never reach the deployed system, the final system. And again, more on this on the second hour on Wednesday. And then the slides close, and I will leave it to you if you are curious on how human computer interaction intercept with the software and design process, whatever process on the software engineer you want to use, from the classical waterfalls to the lean or agile or whatever it is. But the key point is that is always one step ahead of each main point. Thinking about users, evaluating with users, when possible, always done one step ahead. And here there are some example, for instance, with the waterfall process. Okay? Any questions? Okay, yes.
Can you once more say about the assignments that you on the previous?
I will have a slide for that on Wednesday. So you can use that as well, okay? So see you on Wednesday, room 2I, smaller room. So until it fit people is fine, and after you can stand or go somewhere else. Okay? See you on Wednesday.